Hey guys, welcome back, and it is the second video of our series, General Navigation series, and the topic is Earth, our home. First, we'll learn the basic things about our Earth, like the directions and how do we plot directions on our Earth, compression ratio, Earth's rotation, the direction in which Earth rotates, and different types of longitudes and latitudes. So without any further delays, let's get started. Till now, you guys believe our Earth is look like a perfect circle, like this. But in reality, it's much more different. Some theories have suggested our Earth is look like spheroid or ellipsoid, it look like this. And some theories have suggested our Earth is a geoid, it look like this. But in reality, our Earth is an oblate spheroid or ellipsoid. Spheroid or ellipsoid is a kind of a similar term. The main difference between spheroid and ellipsoid is, in ellipsoid, all the three axes, x-axis, y-axis and z-axis, are equal. But in oblate spheroid, two of the axes, the equatorial axis, are equal and longer than the third, which is our polar axis. But in spheroid, our polar axis is shorter than our equatorial axis. Okay. And what is geoid? Geoid is an actual 3D model of our Earth, and geoid stands for Geoid Height Reference. Scientists made this model by the help of our satellites and by the help of WGS-84 satellite system, and this is the exact 3D model of our Earth, and it represents the terrain height on our Earth. But for our navigation exam, we use our shape of the Earth is as oblate compressed spheroid or ellipsoid. So it look like this. As you can see, it is compressed from the poles, and this compression, this flattering of our Earth, we call it is as compression ratio of our Earth. It is the ratio between the polar diameter and the equatorial diameter and indicates the amount of flattering. The ratio is approximately 1/297. This 1/297 we take it is as 0.3% or 1/300. Okay, and by the satellite images, the Earth is in fact pear-shaped with the larger mass is being in the southern hemisphere, and our polar radius is 3432 nautical mile, and our equatorial radius is 3443 nautical miles. So as you can see, our equatorial radius is greater than our polar radius because of the flattering, or because of our Earth is compressed from our poles. So the Earth's polar diameter is approximately 23 nautical mile shorter than the equatorial diameter. So now we come on ratio of ellipticity. So what is this ratio of ellipticity? So it is just a measurement of how much an ellipse deviates from a circle, defined as the major axis minus minor axis divided by minor axis. And major axis is our longest chord and minor axis is our shortest chord. And the value of our ratio of ellipticity is 1/297 or 1/300. Okay, now we'll come on basic direction on our Earth. The direction in which the Earth is spinning is east. North, south, east, west are known as our cardinal points or directions. Northeast, northwest, southeast and southwest are known as our quadrantal directions. I hope you guys know about these directions, but I'll just show it. This direction is our north, this is our south, this direction is east, and this direction is our west. This is northeast, this is southeast, this is southwest, and this direction is our northwest. Okay, so north, south, east, west are our cardinal points or cardinal direction, and northeast, southeast, southwest and northwest are our quadrantal points or quadrantal directions. When viewed from above the North Pole, the Earth appears to be rotating in anti-clockwise direction. So when we are looking from the North Pole, Earth is rotating like this direction, in anti-clockwise direction. And when we viewed from South Pole, it appears to rotate in clockwise direction. And when we viewed from South Pole, it rotates like this, in clockwise direction. Okay, and these direction I have already told you: north, south, east, west. And when we look like this, Earth is rotating in this direction, towards east, because Earth is rotating in the east direction and Sun is also coming from that. Now we come on Sexagesimal System or True Direction System. The Sexagesimal System utilizes the fact that a clockwise rotation of direction from north through east, south and west and back to north is a cycle of 360 degrees. All the directions and heading are in 3 digits. It states that we measure our direction in a clockwise direction every time. Not in aviation, in every navigation form, we measure our direction in clockwise direction. It starts from 000 degree, then comes to 090 degree, 180 degree and 270 degree, and this cycle goes on. For north, it is 00 degree or 360 degree. When we start our cycle, it starts with 000 degree, and when we end the cycle, it ends with 360 degree. And as we can see, all the number and direction are in 3 digits. So it is 000 degree to 360 degree. Okay, so it's 000 degree to 359 degree. 360 and 00 is the same. When we starting the cycle, we say it is as 00 degree. When we are ending our cycle, we say it is as 360 degree. Okay, so for north we have 000 degree or 360 degree. For east we have 090 degree. For south it is 180 degree. For west it is 270 degree. And again when we come on north, it is 360 degree. And we start our cycle or measure our cycle in clockwise direction every time. And as I have told you in the previous video, our earth axis is tilted. Okay, and it is tilted of 23.5 degree. Okay, and we have 2 poles. One is north magnetic pole and another is geographic north pole. So this geographic north pole is constant, it doesn't shift, but this north magnetic pole is continuously shifting. Okay, and why it is shifting? It is because of the movement of molten iron or nickel or elements present in our Earth's core. So due to these metals, our Earth generates a magnetic field. Okay, and if we plot a bar magnet here, we have already know it will change its direction according to the magnetic field. If the field is going like this, so it will align like this. This will be our north and this will be our south because of the magnetic fields. And due to the magnetic field, the compass will always point toward the north pole. Okay, and this is how we measure our direction. So we measure direction in 2 forms, in true form or in magnetic form. When we are talking about true, we are measuring direction with the respect of geographic north pole, and when we measure our direction with respect to north magnetic pole, we call it as magnetic direction. Okay, so suppose this is our compass and it is pointing towards north, and our compass work with the principle of measuring magnetic fields, and it will always points towards the magnetic north pole. So we can say that our compass in this situation is pointing towards this direction, right? So we can say that it is measuring 360 degree or 000 degree magnetic direction, or we can write it is as 360 degree magnetic. And to calculate true direction, we have to apply the magnetic variation, which I will cover in the upcoming videos. So if it is measuring direction according to the geographic north pole, it will be 360 degree true direction. Okay, and this is how we measure our directions on Earth. So this will be 090 degree magnetic, this is 180 degree magnetic, and this is 270 degree magnetic. I hope you got this concept of sexagesimal system or true direction system. And always remember, in sexagesimal system we measure direction in true form. So this is 360 true and 090 true, 180 true and 270 true. The things I have told you about the magnetic direction will gonna come in the later stages in our navigation. So now you have understood about the basic directions, okay? And if we talk about the reciprocal directions are just opposite of the true direction or magnetic direction. The reciprocal direction of 090 is 270, okay? And the reciprocal direction of 360 is 180. And it is 045, so reciprocal direction of it is 225 degree. So for the reciprocal direction you have to either add or subtract 180 degree, okay? If the value is less than 180, then you have to add. If value is greater than 180, then you have to subtract. So let's take an example. If the true direction is 145 degree, so what is the reciprocal direction of it? So it is less than 180, we have to add 180. So the reciprocal direction will be 325 true. And let's take another example. Suppose it is 200 degree. So what will be the reciprocal direction? So it is greater than 180, we have to subtract 180 from it. So it will gonna come out to be 0 to 0 degree. We'll write it is in this form, 0 to 0 degree. We can't write it like this, 20 degree, because as we have learned, all the directions will be in 3 digits. So we have to write it like 0 to 0 degree or 090 degree. We can't write like 20 degree, okay? But above 100, we can write 010 degree, 120 degree, and so on till 360 degree. Now I hope you guys understood this concept of sexagesimal system or true direction system, how to plot a direction on Earth, how to write directions. Now we're gonna come on latitude. The latitude of any point is the arc, angular distance measured along the meridian through the point from the equator to the point. It sounds much more complex, but it is very simple. You just understand it like this. All the horizontal lines plotted on our Earth are latitudes, okay? And all the vertical lines plotted on our Earth, these all are longitudes. So horizontal lines are our latitude and vertical lines are our longitude. But if we go according to the definition, then it is, if we take an arc or an angle and we take our equator, so you have know this is equator as a reference, and we take it to the point on our Earth's surface, this will make an arc of 40 degree. So this latitude will be our 40 degree latitude. If we make an angle like this angle is suppose 20 degree, this is our latitude of 20 degree. And if we make angle of this is suppose 80 degree, so this will be our latitude of 80 degree, okay? Equator divides northern hemisphere and southern hemisphere. This is our north hemisphere, this is our south hemisphere. So this will be 20 degree north, this will be 40 degree north and 80 degree north. And if we make arc of like again 20 degree angle but in southern hemisphere, so this latitude will be of 20 degree south. And same goes with if we make an angle of 80 degree in the southern hemisphere, this angle will be this latitude will be of 80 degree. As simple as this. So just remember, all the laty lines are our latitudes and all the khadi lines or the vertical lines are our longitude. Same definition for the longitude. The longitude of any point is the shorter distance in the arc along the equator between the prime meridian and the meridian through the point. So prime meridian is our datum meridian, okay? It is our main meridian. We are taking all the references from this meridian and it is of 0 degree, same as equator. Like equator is of 0 degree, we take equator as 0 degree, okay? So these prime meridian and equator both are our references to measure longitude and latitude. For longitude, the prime meridian is our reference. So now we are making an angle of this, suppose this is 40 degree angle and we are taking prime meridian is our datum meridian, And if we make an angle, if we make an arc of this is our 40 degree. So this longitude is of 40 degree longitude. And if we make an arc like this, suppose this is 60 degree, so this will be our latitude 60 degree. And we know if we measure towards the east direction, okay, it will name as 40 degree east and 60 degree east. And if we measure in west direction, suppose we are making this arc and this is same 40 degree, this latitude will be our 40 degree west, same as this arc. Suppose this is 60 degree, so this latitude will be our 60 degree west. So for latitudes, it goes till 0 to 90 degree north. 0 is our equator. And for southern hemisphere, it is same 0 to 90 degree south. But for longitude, it goes till 0 to 180 degree east or west. Okay, so what is parallel of latitude? All these horizontal lines are our parallel of latitude, and all these vertical lines are our parallel of longitude. And when we look them in one frame, it will gonna look like this mesh. And this mesh, we call it is as reticule. Guys, sorry for my handwriting, I know it's very bad, please ignore this. And we know all the vertical lines are our longitudes, and all the horizontal lines plotted on our earth are our latitudes, or parallel of latitudes, or parallel of longitudes. And these lines are imaginary lines, there is no such real lines plotted on our earth. Okay, now I'll tell you how to write a particular position or how to write a coordinate on our earth. So we'll take this is our prime meridian, and this is our equator. We have taken our datum or references. Okay, now we'll plot all the latitudes and longitudes. This is our 10 degree north, 20 degree north, 30 north and 40 north. We are just taking them as a reference. It not represents the actual, because if we are represent the actual, this one should be 80 degree. Okay, and this will be 10 degree south, 20 south and 30 south till 90 south, and here also it will till 90 north. Okay, same will take for meridians. This meridian is our 10 degree west, 20 west and 30 west, and it will go till 179 west. And this longitude is 10 east, 20 east, 30 east till 179 east. When we come on 180, we can say it is as both east and west. Okay, and it is just opposite of our 0 degree prime meridian, and it is also look like this. Suppose this is our prime meridian, this is of 0 degree. Okay, and this will be its anti-meridian. Okay, this is of 180 degree. Okay, suppose this meridian is this one is 30 degree east. If we take reciprocal of it, so its anti-meridian is this one, and it is 150 degree west. How we have calculated it? We have subtracted 180 minus 30, so it is 150. Same goes for this is 40 degree west. So what will be its anti-meridian? Its anti-meridian will be this. I am just representing it. Okay, so its anti-meridian will be 180 minus 40, and it will gonna come out to be 140 degree east. Okay, so this is how we write meridians and anti-meridians. Okay, now if someone is standing here, how do we write it? So first we'll take latitude. So it is on latitude 20 degree north. Then we'll take longitude. So this longitude is also 20 degree east. So it will gonna come out to be 20 degree north, 20 degree east. That's how we write coordinates or position on our Earth. Let's take another example. Suppose someone is standing here. How do we write it? First, we'll write its latitude, that is 30 degree north, then longitude 30 degree west. Okay. Another example, someone is standing here. So we'll write it is as 20 degree south and 10 degree west. Okay. This is how we plot coordinates or position on our Earth. I hope you got this concept. And same thing represents here. This is our prime meridian, and in the eastern sides we have eastern longitudes, and for the western sides we have western longitudes. Okay, and this is our prime meridian, 0 degree, so its anti-meridian is 180 degree, and this is how it look like. It is 120 degree west, it is 120 degree east. So now there is one more term, geocentric or geodetic latitude. Till now you guys have studied about the latitude based on considering Earth a perfect sphere. But we know Earth is not a perfect sphere. It's an oblate spheroid. So for more precise latitude, considering our Earth is an oblate spheroid, we use a term geodetic latitude. Okay, so what is this geodetic latitude? Geodetic or geographic latitude is the smaller angle between the normal 90 degree to the meridian at a point on the spheroid and the plane of the equator. Sounds complex, right? But just remember this. The basic difference between geocentric and geodetic latitude is geocentric latitude is based on considering our Earth is a perfect sphere. Okay. For geodetic latitude, we consider our Earth is an oblate spheroid. The values of these two latitudes are same at the equator and near the poles, but it will vary on 45 degree north-south latitude. The values gonna come out to be different. Okay, and the max difference will occur is 11.6 minutes, and it's also written here the maximum difference between geocentric latitudes occurs at approx 45 degree north south and is about 11.6 minutes of arc. Okay, and guys, please remember this, the maximum difference occurs at 45 degree north south and it is about 11.6 minutes of arc. It might get asked in exam, and I have seen this question a lot of times. Now I hope you guys got this geocentric and geodetic latitude. Now we'll come on the special cases of parallels of latitude. So we have some different latitude names. First is Arctic Circle, the parallel of 66.5 degree north. This one in northern hemisphere. This one is our Arctic Circle latitude, and it is about 66.5 degree north. Okay. And Antarctic Circle, the parallel of 66.5 degrees south in southern hemisphere. This one is our Antarctic Circle, 66.5 degree south. Okay. Now it comes the Tropic of Cancer, the parallel of 23.5 degree north. The sun is overhead of the Tropic of Cancer on midsummer's day in northern hemisphere. Already told you this in my previous video, the first video of solar system. This one is our Tropic of Cancer line. It is about 23.5 degree north. Okay. And Tropic of Capricorn, the parallel of 23.5 degrees south. The sun is overhead the Tropic of Capricorn on midwinter's day in northern hemisphere. This line, this is Tropic of Capricorn, and it is about 23.5 degree south. Just remember these terms and its value. Now comes the Great Circle and Rhumb Line. So what is Great Circle? A circle whose plane divides Earth into two equal hemispheres is called a Great Circle. And what is a Rhumb Line? Rhumb Line, a line which cuts all meridians at equal angle, is called Rhumb Line or a constant direction line. Small circle is just a part of a Great Circle. Okay. So what actually is Great Circle? As you have learned from a definition, it divides our Earth into two equal hemispheres, or you can say it is the shortest distance between any 2 points on our Earth. Why it is called great? Because a disc cut through the Earth in the plane of Great Circle would have the largest area that can be achieved. From Great Circle, I just want you guys to learn one thing. It is the shortest distance between any 2 points given on our Earth. Okay. Properties of a great circle. Shorter arc of a great circle is the shortest distance between any two points on the earth. Okay, its radius, diameter and center is same as that of the earth. Only one great circle can be drawn between 2 points unless they are diametrically opposite. Okay, in such case infinite number of great circle can be drawn. Radio signal follow great circle path, which is the shortest distance between any 2 points on our earth. Now, what is rhumb line? A line which cuts all the meridian at equal angle is called rhumb line or a constant direction line. Just remember, it is a constant direction line or a line which cuts all meridians latitude at same angle. As you can see here, it's cutting this latitude at same angle x. It also cutting this latitude at same angle x. So great circle is the shortest distance between any 2 points on our earth, and rhumb line cuts all the meridians or latitude at same angle. Okay, what is this small circle? A small circle is any circle on earth other than a great circle. The circle which is not a great circle is a small circle. Okay, it will also be a shortest distance between any 2 points. Okay, properties of a rhumb line. Along a rhumb line, an aircraft follows a constant direction path. It is not the shortest distance between any 2 points. Any rhumb line spirals up towards nearer pole. Why it is saying that it spirals up towards a nearer pole? Because it is a path of a constant angle or a constant bearing or a constant heading. Okay, and our earth is also a sphere or an oblate spheroid. So it will not gonna be look like a straight line because our earth is a kind of a sphere. Okay, as you can see, this is our rhumb line. How rhumb line looks on our earth surface. It is making the same angle with all the meridian. This angle is also x, this one is x, and this one is also x. And this is how great circle looks. It is the shortest distance between Moscow and Vancouver, and it is not making the constant angle because it is the shortest path between any 2 points. It can also look like this. Rhumb line is a constant direction line making equal angle with all the meridians or longitudes, and great circle is this path. Okay, it is the shortest distance between Moscow. You can say that it looks like a more distance, but in actual it is not, because our earth look like this. Our earth is a kind of a oblate spheroid, so this will gonna be the shortest distance between Moscow, and this will gonna be the rhumb line between Moscow, which are making the constant angles with all the longitudes or meridians. Okay, so this is all from great circles and rhumb line, and this is all from our chapter Earth. I hope you guys got all the concepts. If you are having any doubts in any concept related to this chapter or anything, just let me know in the comment box. And if you guys want me to make a separate video for numericals related to latitudes, longitude, do let me know in the comment box. Okay.